In this video, we are going to look at coterminal angles. So angles in standard position, which means your vertex is on the origin, your initial side is on the positive x-axis, with the same terminal side are called coterminal, together at the end. So coterminal, they have the same endpoint. Angles. Give two coterminal angles for each angle, one positive and one negative. So let's start over here and let's talk about first what it is that we're looking at. So on this one, the angle we're looking at here is that 90 degrees. Now we'll talk about this part momentarily, so just ignore that for right now, that 90 degrees. So going counterclockwise, standard form, is going to be 90 degrees, right? Going clockwise, it would be negative 270. Negative because we're going clockwise, 270 because it's 90, 90, 90, 3 times 90, it's 270. Now, what I want you to notice is that if I take that 90 degrees and subtract 360, that's going to give me the negative 270. So that's what's always going to happen. Going forward, going backwards, you're going to be able to subtract the 360. Now, if I want another coterminal angle, but I want it to be positive, what I'll have to do is loop around and then come back. So I can go loop all the way around and then come back to that 90. That angle would be 360 plus 90. So my two coterminal angles can be given by subtracting 360 by adding 360. Now, keep in mind I could add 360 again and again and again and again. I could do this infinitely many times, but those are going to be the two that are closest to the original one. So taking a look at example 10 here, first of all, let's draw our angle. You don't really have to in order to do it, but let's do it anyway. 65 is less than 90. I probably didn't draw that quite steep enough. Let's try it again. Not that it really matters. So there's my 65. So let's do the other positive one. Let's loop around once and then come back to it. So that would be 360 plus 65, which is going to give me 425. Okay. Now, to go backwards, let's do this one in red. Starting at my initial side and coming backwards, I'm going to do 65 minus 360. And you know what? Let's stay consistent. Not that this really matters, but then my notes will be, I'm going to add 360, and then I'm going to subtract 360. For the subtracting one, or for the adding one, it really doesn't matter which order I go in. For the subtracting one, I want to do the 65 first because that's going to give me my nice negative number. So when I do 65 minus 360 and I get negative 295, see how it already gives it to me negative? Okay, now you're going to do number 11 as part of your assignment here. Let's look at the one with pi. So this time it's measured in radians. So the first thing I want to do is talk about my four corners, my quadrantal. I have trouble with that word for some reason. Values, what I call four corners because it's easier to say. I want to talk about those in radians. So we already said in degrees, it sends me, whoops, that's not 360. That one's 360, right? And for, now, in radians, the 0 is going to stay 0. The 180 is pi. We already talked about that. 90 is half of 180. So in radians, it's going to be half of pi. Okay, and then 270 is 3 times 90, so I'm going to do 3 times pi over 2. 3 pi over 2. And then the 360 is 2 full revolutions. That's 2 pi. So these numbers are, it's really worth your time to memorize. 0, 90, 180, 270, 360. And then pi over 2, pi, which is 2 pi over 2 if you want to think of it that way. 3 pi over 2, 2 pi, which is 4 pi over 2 if you want to think of it that way. The reason these values are important is because then if I say to you, you know, 6 pi over 7, you know that that's going to be about 6 pi over 7. Yeah, it's going to be about right there because 7 pi over 7 would be pi. So it's going to tell you which quadrant you're going to be in, which is important to us. Okay, now as far as our coterminal angles go, we're still just going to do the same thing. We're going to add 360, but we're going to add it in as 2 pi instead. And we're going to subtract 360, but we're going to subtract 2 pi instead. Okay, so here we go. Let's first of all decide where our 13 pi over 18 is. Ready? This is a little bit odd, so you're going to have to really kind of listen, right? So 13 pi over 18. Let's do everything in terms of pi over 18. So this is going to be 0. This is going to be 18 pi over 18 because that would be pi. And then this is half of that, so that's 9 pi over 18. That's pi over 2. So 13 pi over 18 is going to fall somewhere in there. Okay, I don't really care where. I just want to make sure it's in the second quadrant. The quadrant is important. All right, now to find my angles, first I'm going to do the one that loops around and gives me another positive. So that's 2 pi plus 9 pi over 18. So I'm going to do 2 pi. Whoops, you know what I'm going to do? I'm going to stay consistent. I am going to do, don't know why it's not letting me change my thickness here. I am going to do 9 pi over 18. Sorry, no, I'm not. I'm going to do 13 pi over 18. Plus 2 pi. So this is going to give me the one where it loops around. And I'm going to be super lazy here. I'm going to go to my calculator and go 13 over 18 plus 2. It's not really hard. Make that 2 into 36 over 18. But 49 over 18. When I go to my calculator, I don't punch the pi in. But when I write it down, I need it again. So 49 pi over 18. And then to find the negative one, so the negative one, I'm going to loop clockwise. I'm going to come this way. I'm going to do 13 pi over 18 minus 2 pi. Then again, I'm going to be a little lazy. I'm going to go 13 fraction 18 minus 2 and switch it to an improper 23 over 18, negative 23 over 18. But don't forget the pi. So when I type it into my calculator, I'm not typing in the pi because I don't want it to approximate it. I want to leave the pi value there. But I can't forget to put it in when I put it there. Okay, you're going to do number 13 in the assignment.